Here we're going to focus on writing linear equations from their graphs or given a bunch of information about them. First of all, let's think about the forms of linear equations that we know about. One that we probably like the most is slope-intercept form, mainly because it's the one that we've used the most, we're most comfortable with it. It's easy to graph given an equation in slope-intercept form. But I'd say one that's equally as easy to use is point-slope form. And that's one that says y minus y1 is equal to m times x minus x1, where m is going to be the slope. And then instead of knowing what the y-intercept is, we know what any point on the line is. The third one is standard form, ax plus by equals c. Now there's different reasons for maybe using or starting off with one of these different forms. Slope-intercept form, but if we're given a point, or if we're given the y-intercept and a slope, then we would definitely want to use slope-intercept form. But if we're given some other point and a slope, then we'd probably want to use point-slope form. Standard form is rarely used. Well, I wouldn't say rarely, but you could use this if you're given two intercepts or if you're given two slopes. Two different rates or something like that. There's some use, but we're probably going to stick with slope-intercept form or point-slope form first. So let's write an equation in this line given its graph. Now we have to kind of come up with all the information that we need by looking at the graph, and there's a couple things. First of all, right there we can see where the y-intercept is, and it crosses the y-axis at -2. That means that our y-intercept is -2. Also, we can find out what the slope is just by counting, by going from one point to the next. Remember, slope is rise over run, or that vertical change to the horizontal change. And for the vertical change, it drops 3 units. So it rises -3 units. And then its horizontal change, its run, is 4 units. So its slope is -3 over 4. That's everything we need to come up with its equation, just using a slope-intercept form, y equals mx plus b. We take these numbers and plug them in where they go. Y equals m, the -3/4, x, plus b, -2, is its y-intercept. And we're done. One small thing about this, though, I noticed just as I correct papers and stuff, a lot of people want to write their fractions like this, -3/4. And they'll write -3/4 x minus 2. And that looks great, when you're writing it down and you know what you mean, and that feels good. But the problem is, when I look at this, it looks to me like that x is in the denominator. So it's not good to write your fractions like this. Just to clean them up, what we should do is write our fractions vertically, 3/4. And then when we write that x, don't put the x down in the bottom. That still looks like it's in the denominator of the fraction, and we don't want that. The x actually is being multiplied by 3/4, so it belongs in the top. So if you're going to put it on one side of the fraction, put it on top. But what you really want to do is just put it out in front. Put it right in the middle out in front. So then we can see that 3/4 is being multiplied by x. How about we write an equation if we know that the line passes through the point 54 with a slope of -3. Well, now we're given a point and a slope. So we should use point-slope form. So let's grab point-slope form first, which is y minus y1 equals m times x minus x1. And what we have to do is just plug in this information for some of the variables. We know that the slope is -3, so that's what we're going to plug in for m. This x and this y are variables. It's x1 and y1 that are the x and y coordinates of the ordered pair. So for x1 we plug in 5, and for y1 we plug in 4. Notice that in our point both 5 and 4 are positive, but when we look at them in the equation they look negative. Okay, that's because it's y minus y1 and x minus x1. So it is supposed to be the opposites of what we see inside of there. Now, if we needed to go the extra step, could you take this equation and turn it into slope-intercept form? And it's really not that hard to do. All we have to do is add 4 to both sides. That gets the 4 off of the left-hand side and gets y alone. If we distribute the negative 3 throughout, we get negative 3x plus 15, and remember that we added 4 to both sides. Now we're not adding 4 inside of that parentheses, we'll just add 4 right at the end. Then that simplifies to negative 3x plus 19. And we can see the slope is still negative 3, which we always knew, and we can also see the y-intercept is at 19. How about if we want to write the equation of line passing through this point, negative 2, 3, and now it's perpendicular to y equals negative 4x plus 1. Well, knowing that it's perpendicular talks about the slope, because the slope of the line that we're looking at here is negative 4, and if we want the one that's perpendicular to it, the slope we're going to use is the opposite and reciprocal. So instead of being negative 4, it's positive 1/4. So there's our slope. Here's our point. Let's use point slope form. Y minus the y coordinate equals slope times x minus the x coordinate. Now look, we're subtracting negative 2, so we should simplify that. Y minus 3 equals 1/4 times x plus 2. And there we have an equation of our line. Write the equation of line passing through 2 points. Now when we're given 2 points, we don't necessarily know what the slope is offhand, but we can find it. Because remember, slope is the rise over the run, the y's over the x's. So just subtract the y coordinates on top and the x coordinates on the bottom. Negative 2 minus 10 is negative 12. 5 minus 2 is 3. So this thing is going to simplify to negative 4. There's our slope. And we can pick either one of these points and we'll have a point. So I'll just take the first one. It really doesn't matter which one we pick. But y minus the y coordinate equals slope, negative 4, x minus the x coordinate. Now, we could turn that into slope-intercept form. I'm going to distribute the negative 4 into negative 4x plus 20. And this is really subtracting negative 2 is the same as adding 2. So that's just like a plus 2. So I'm going to subtract 2 from both sides to get that to cancel. Minus 2. And y equals negative 4x plus 18. The reason I want to do that is because I often get this question, well, what if I use a different point? I mean, right now we used 5, negative 2 to come up with this equation. But what about if we use 2, 10? Well, we could start with point slope form again. Y minus the y coordinate is equal to the slope, same slope, x minus the x coordinate. Okay. That's also a legitimate equation. But let's turn it into slope-intercept form. I will distribute the negative 4. And now this is minus 10, so I'm going to add 10 to both sides. And wouldn't you know, we get the same equation, y equals 4x plus 18. Okay. So what that means for us is that when we're trying to put something into point-slope form, it may look a little bit different each time that we do it. But we're still getting a correct answer. One last problem, word problem. What if you have a $30 gift card for downloaded music and one company charges 79 cents a song and another one charges 99 cents a song? Write an equation that models this situation. And when we quickly look through the problem, let's see, we got $30 in total that we can spend on music. One place charges 99 cents a song and one charges 79 cents a song. And so that dollars per song or the cents per song, that's a rate of change. Whenever we have one unit being related to another like that, that's a rate. And what we find out is, I mean, we can think about it this way. Thinking about this first company that charges 79 cents per song. If we were to buy one song, it would cost 79 cents. If we were going to buy 2 songs, that would be $1.58. If we were going to buy 10 songs, it would be $7.90. If I was going to buy X number of songs, it would be 0.79 times however many songs we buy. And for the second company, the same thing would happen. where we would pay 99 cents for every song that we would buy from them. In total, we would spend $30 between the two companies. And here we have an equation that models the situation. This is what I call a double rate problem, because when we looked in the problem, we saw 79 cents per song and 99 cents per song. And each of those are the rates for two different companies. And in other problems, it might be two different people or companies or whatever. And what you're going to do is multiply the rate times a variable. Add it to the other rate times a variable. And that'll give us our total.